so I want you to write this down on your guys' paper. I know you've all done the scavenger hunt around campus, and imagine these are your only two stops. And the distance between the Coleman Center and Gelke is 700 feet, and 800 feet between Gelke and Bonnie Castle. So imagine that that I gave you this before you went on the scavenger hunt. And whenever you're done writing down, you put your pencils down. Okay, so Larissa, just from looking at this picture and the information given, what do you think would be your quickest route to get to both places and to the Coleman Center last?
Where do I start at? Oh,
You'd start Gelke.
okay.
So basically, okay, what are your options in how you can do this? You start at Gelke.
Yeah.
Now what?
You can go to Bonnie Castle.
Go to Bonnie Castle, and now what?
Go
How?
that way.
Okay, so would you go? You go this way, or you could go back to Gelke and back here, right?
Go that way.
Straight to Coleman.
But how do you know that the distance from here is going to be less than going this way?
Because,
Technically.
because it's the direct route, and I'm not stopping.
Costco, do you know for a fact, looking at this, that this is going to be your quickest route?
Yes.
Yes, but this is a really serious competition, and you cannot take any chances. So you want to know exactly how far this is. Do you know how you find that out?
Yes.
Because we want to know that this distance is going to be less than this.
Is there an equation for this?
Yes.
A squared.
Hold on. Hold that. Because I want to make sure. Hold on. Okay, so why do you have the idea that there might be an equation? Because just by looking at this.
Because you have to find that. You have to find this.
It's the hypotenuse.
You have to find
Hypotenuse. What
this.
does the hypotenuse have to do with? What kind of shape are we talking about?
Triangle.
What kind of triangle?
Right triangle.
Right.
So it has to be a right triangle, right?
Yes.
Okay. So what we're gonna do is I want you. That's why I had you write this on your paper. I'm gonna come back to this. Jot down any ideas you have right now. What you just discussed, basically. We're gonna come back and we're gonna end up solving this problem.
I just want to have fun. Never mind.
Okay.
Thanks, Rachel.
You're welcome.
Should we write this down too?
Hold on one second. I'll let you know what you're gonna do this in a minute. Okay, so what we're going to do next, I'm going to have you split into two groups. I know we're not even right now, but you'll end up working together. So I'm going to have Ellis and Larissa work together, and Casco, you're working on right now, but don't worry because you'll all end up doing the same thing. So group one is going to be, I'll give that to Casco. And I want you to draw this on your paper, this shape. So we're going to say it's inches.
The triangle you want me to draw?
Yeah, draw the triangle with your ruler. I want you to measure out 8 inches, 6 inches. I want you to draw this triangle, and I want you to, using a ruler, find that missing length.
Gotcha.
Now, group 2, you're doing something completely different.
Can we do centimeters instead?
That's fine. You have 5 symbols you can use, okay? So you have an 8, a 6, an equal sign, a multiplication sign, and a square root. I want you to do whatever you can to get the answer of 10 using all of these symbols. You can use them in whatever order you want, you can use multiple of some of the symbols if you need to. You just want to end up with the answer of 10. And also don't forget you have those red, green, and yellow cards. If you feel that you're struggling, put out the card, I'll pay attention, I might be able to give you a little help. I'm going to give you guys about 10 minutes or so, and Kelsey, whenever you're done with that, you can start working on the other problem if you would like to.
talk about this?
Yep.
Okay.
I would love for you to talk about it. What are you thinking?
Yeah.
Okay, well, write out some combinations. You're gonna use all of them.
Okay, so, right there.
But you want to use all of them. You can use them anywhere, but you have to use all of them. Keep thinking, keep thinking.
You just want me to
I
measure
am.
this one.
Yeah, measure that one, yeah.
Just even.
I'm gonna take some work on that. Use your calculator, just keep plugging stuff in and see what works. And make sure even if things don't work out, you're writing them down so you know what didn't work out and what did work out. Okay, keep in mind.
Can we add other things?
Yeah, no, I mean you're gonna use. I'll actually give you guys one little hint for this. How else can you write 6 times 6? So that, in this case, this can be considered the same thing. So you can use, you can use multiplication all the time, but if you don't want to write it 6 times 6, you can use 6 for it.
Wait, what did you say? Completely
Oh, wait,
wrong,
wait.
I just said.
Oh.
Does that make sense?
Run.
Oh. Like the way you did bridge.
Is that right? No, wait.
Wait, why did you do that?
No.
Wait, what is that?
Wait, wrong.
Plug it in your calculator, see what comes out.
What are we doing? That's what we're playing in?
Okay.
Yeah, then, all right. Oh, okay. 6 right? 6 squared times square 8 squared equals 40.
But keep in mind your order operations. Try.
Oh, Jesus. And then
Now-
should I read that?
See if that works.
That's good.
You got about 30 seconds. If you don't have it, it's okay, but that's how much time I'm going to do.
Excuse me, John.
How does the 6 components 1.1 subtract?
You done with your problem?
Yep.
Okay, so what you just see what I just did?
Yeah.
So you have it, right?
Yeah.
Alright, so everyone's done?
Yeah.
Alright, so first, Kelsey, what did you get when you used a ruler and measured? Are you guys done?
Yeah, I was writing up.
No, it's fine, I'm just gonna make sure. Okay.
Yeah.
So Kelsey, what did you get for the side that you measured using a ruler?
10 inches.
You did it in inches, you didn't do it in
Well, I did
centimeters.
it in centimeters, but
Yeah.
I would have done the same.
Okay, so she got 10 inches. Think about it, it's all connecting. So what did you guys get for this group
10.
2? Okay, you got 10, that's what our goal was.
Yes.
How did you put together all these symbols to get that?
You do.
Want me to do it?
No.
Okay, well,
Rachel.
we came up with 6 squared plus 8 squared equals 100.
Mm-hmm.
And then we took the square root of 100 to make 10.
Okay, so now I want you to think of, so obviously these numbers, we're all using the same numbers here.
Yeah.
So how can you relate this equation to what we did here? So if we did not have a ruler, how could you find this, Kelsey?
The Pythagorean theorem equation. I'm sorry.
Okay, alright, so
Yeah.
we're saying with a right triangle, we can only do this with a right triangle. If you want to find a side, how are we going to apply this? I want to write out a general equation. Larissa, I want to write out a general equation with variables.
Okay, a squared plus b squared equals c squared, or x squared, or would it be c squared? It's c squared.
Okay, but from what we've learned, from what we've already learned about equations, how else could you, is that the only way you could write that?
Guess so?
Does it matter if it's an A or?
It could be b squared plus
Oh,
a
yeah.
squared equals c squared.
But you can have, question.
Rachel?
You can already have the c squared though, so you could like flip it.
Right, but could I have x squared plus y squared equals z squared?
Yes.
They're all variables. They're all variables, so these are just
X and Y are
subbing
just
in for a
numbers.
number. But what we're going to learn is that it does matter what is your A, what is your B, and what is your C, or X, Y, and Z. But it doesn't matter what kind of variables you use. We're going to use the A squared plus B squared plus C squared. They all work though, but that's the one we're going to work on. So in our case, what was your A, what was your B, and what was your C?
A was 6.
Okay.
B was 8. And C was 10.
Okay, what I want you to do is I want you to switch. I want you to try it with B is 6. I'm going to write that differently. A is 8, B is 6, and C is 10, and I want
You wrote B equals
to, sorry. I want you to see if this works out. If this still works out, are you going to get the same answer? Plug that into your computers. I'm just going to erase these other equations. So we know this one works. Put your calculators down when you're finished. Alright, Larissa, did it work?
Yeah.
Alright, it worked. Now I want you to try one more thing. Try A is 8, B is 10, and C is 6. Kelsey, does it work?
No.
Why don't you think it works?
because c squared, which is 6 squared, only equals 36. But if you add 8 squared and 10 squared, you only 64.
Do you guys think it works?
No.
It doesn't work.
No.
You got the same thing? Okay. So basically what we're going to learn here is, like you guys used before, hypotenuse. C is going to be your hypotenuse. It's always your hypotenuse. These two are your legs. You can interchange the legs, but you cannot switch up your hypotenuse. So A and B are your legs. So A is a leg. I want you to write this down in your notes. A is a leg, B is a leg. and C is your hypotenuse. So what is true about what's always going to be true about the hypotenuse compared to the legs?
It's always bigger.
It's always the longest side. So that's how you know what the hypotenuse is, the longest side. And in a right triangle, no matter what kind of right triangle, you could have one like this, one kind of like we've had. All of these right triangles, this is always going to be the longest side, your hypotenuse. So you don't have to worry, as long as it's the longest side, that's your hypotenuse. Okay, so I'm going to go back to the problem we were doing before, and now we're going to apply this, and hopefully from what you guys discovered on your own, you're going to be able to figure it out. What's the quickest route? Back to our Coleman Center. I want you guys to work on your own, apply what we've used, what you guys came up with on your own, and I want you to find out if it's true, if this is the shortest route. Remember your cards if you're struggling. Don't be afraid to put those cards out. Everyone has this drawn, right? I can erase it. And again, once you're done, make sure you put your pencils down. Chelsea, are you done?
Yes.
Okay. All right, Rachel, I want to give me your first step in figuring this out. What's the first thing you did?
I did 700 squared plus 800 squared equals c squared.
Okay, so what did you get for 700 squared plus 800 squared?
1,130,000.
You got?
No. 1.
What's one?
That equals c squared. Okay, so we're trying to find c. What was your next step, Larissa? Okay, so if 1,130,000 equals c squared, what can you do to get rid of that squared?
Oh, you take square root.
Okay, square root. So square root of that of 1,130,000 is what? It's going to equal your c. C equals what? What'd you get?
She's got the good calculator.
Kelsey, what'd you get?
1,063 over 0.063.
Okay, so what is that? What is c? What did you guys find? What value is that? What was that for? What's the term we used?
Hypotenuse.
That was the hypotenuse of our map, right? So, you had 700, 800, and 1,063, about. Okay, so what was your next step to find out if this, so going straight from Bonnie Castle to Coleman Center was shorter than going to Galkey and then to the Coleman Center? Larissa.
You
You have two routes, okay? So you have just from Bonnie Castle straight. You found that, right? So that was that 1,000 feet. So now your second route would be to go to Gelke and then up.
They just add those two.
Add those. So what's 700 plus 800?
1,500.
Alright. Rachel, so what are you gonna do next? You're comparing. What are you comparing here? What are we comparing? We're comparing the two routes, right?
Yeah, the two.
Okay. So you have this 1,063 and you have 1,500. What's shorter?
1,063.
So what do we figure out?
The difference.
This whole, I know, but in the whole big picture, what do you figure out?
Pilot?
Yes. Which told us what?
Quickest way.
It's the quickest way, right?
Yeah.
So that's kind of a real world problem where you could use this. What I want you to do is at the top of your page, you guys did a great job. I want you to write at the top of your page what we just did. You discovered it on your own, but it's called sorry. So believe it or not, you guys just discovered the Pythagorean theorem all on your own. And I want you to write below it what you guys found. And that is what we're going to be using from now on. Once you have that written down, put your pencils down. Alright, so we're going to do a couple of examples. A couple more examples to practice this up. Alright, so I want you, on your own, I want you to find this one. Find your hypotenuse.
I'm not sure what.
You guys have smartphone.
It's not smart as a calculator.
It does the same thing.
It doesn't have a square root.
Yes, it does. Keep your idea for you.
Mine doesn't. You can use your hand.
We're sorry, you having some issues here.
I just.
You need something?
No, well, do you have another calculator?
The square root is over here.
Because if you use your hand, you think it's this one. That's the funniest.
Oh, shit.
That's the thing, isn't it?
No, keep it 3.
Maybe that is.
It's a cube root and a square root. Yeah, the one with the 2 is a square root. Oh, no, it's just not written like that. The one with the 2 is square root.
Okay.
I don't know what it is, but I don't know.
I didn't know sorry to. Oh, I could use my head on this. Yeah, they're not flat, they're not deep.
Alright, Kelsey, what was your first step?
To do 1 squared plus 6 squared.
Okay, well, why'd you do that? What did you think of before that? You might not have had to really think it out as a step, but you did think about it.
I had to figure out which one was my hypotenuse.
Yeah. So we know we kind of already is given because it's a C, but I could use some other variable. But that's your hypotenuse you're solving for. So you know this is going to be A and B. You can go either way, which we did. So what did you say you did? 1 squared?
Plus 6 squared equals 6 squared.
Okay, so what did you get for 1 squared plus 6 squared?
37.
What's your next step?
I took this for 37.
So really we're doing just so you guys understand, we're doing the square root of both sides. Because when you do the square root of something squared, that just cancels it out. So now you have a C. So what's the square root of 37?
6.08.
Alright, so C equals 6.08, which is your hypotenuse. Great. Okay, now I'm going to switch it up a little bit on you guys. We're going to do this one as a class though. Now what if I do not give you the hypotenuse? Or I did give you the hypotenuse, I'm sorry. What if I didn't give you one of the legs? So say I didn't give you B. It's gonna get switched up a little bit. So Rachel, what do you think you're gonna do first?
Set up the green.
Okay, so we set up the equation, so what's our hypotenuse?
21.
21. Okay, so I can put that in for C. So we're gonna say 21 equals. Alright, what's the rest?
Well, for a squared would be 16 squared plus b squared.
Okay, perfect. So now we're solving for B. This is the only difference. We're solving for B instead of C. So what would be our first step? What's up, Larissa?
Would you no.
No,
Yes.
go ahead. What do you think?
Subtract.
Okay, so subtract. What do we subtract right now? What's something we can do first?
You gotta get rid of the squares, right?
Okay, so at least for this one, you could do the 16 squared. So what is that? You can put it in your calculator.
4.
No, 16 squared.
16 squared, not square root of 16.
Oh.
Whoops, that's awkward.
256.
Alright, so 256. Now I want you to think what you were thinking. Okay, so you're saying subtract, but what are we subtracting? Where are we subtracting it? We're trying to get the B by itself. That's what we're solving for.
Oh yeah, you subtracted 250.
I have a question.
What's up?
Aren't you supposed to square root or do 21 squared?
Okay, so if you want to do that. Alright, so Larissa, where am I subtracting it from?
You subtract 256 from both sides.
From both sides, right? So we're always doing everything we do, we're going to do it from both sides. So what happens to the left side when I subtract 256?
0.
Okay, so we just have B squared equals what? What do we get?
185.
Is that what everyone else got?
Yes.
Okay, Rachel, what do you do next?
Square root both sides.
Okay. So what happens when you do the square root of B squared?
It just becomes b.
This becomes B, and then what's the square root of 185?
13.60.
Is that what everyone else got?
Yep.
You said 60?
Yes.
So we just make 13.6. Okay, so our B is 3.6. So we're going the same route, it's just you have to pay attention what you're solving for. I might not give you B, I might just have a blank. Because I know that makes it a little easier. So you can use that as A or B, but I may just give you a blank there. Okay, so before you guys leave, I know we don't have much time. Eraser. Okay, so before you guys leave, I have one more assignment for you. Pull out a blank piece of paper. And I want you in, I'm going to write this on the board actually, in 3 or 4. 3 or 4 sentences, I want you to explain in your own words what you learned about the Pythagorean theorem today. This can be, how you can apply it in your everyday life. This can be just step by step of kind of what we did today. It's up to you, but I want to know what you know. What did you learn today?